people can argue that these things are secure until someone finds a way to hack into them.
So let me ask, does it mean that because someone can come and break your front door,
Yeah.
you won't lock it at night? Right? What would you instead do? Would
Well,
you
I'll
lock
still
it
lock
and make
it.
it? Yes, make it harder for someone to break
Exactly.
in. It doesn't mean they can't break in. Like people break into banks.
Yeah.
It's not your house that they can't break
Even
into.
burglar proof.
Exactly. So
All right, what's up, everybody? Welcome back to this episode of the Comrades podcast. With me here, I have Stefan Froelich, who is a senior software engineer in the industry. Stefan, it's nice to have you here.
thank you.
I would like you to share with us you.
The name is Stefan Froelich. Half Ghanaian, half German, born and raised in Ghana. Lived my entire life here, so I consider myself Ghanaian every day, all day. I got into tech right after university national service. I worked for a bank in their IT department as a help desk officer. And gradually from there moved up. I already had an interest in programming, so I quickly pivoted to programming about 6 years or 7 years after that. And it is what it is since then.
That means you have very much knowledge about the tech ecosystem in Ghana.
Oh, about the ecosystem? Yeah. I've been in it for quite a while.
Okay.
So I've seen it change. I've seen it grow.
Mhm.
I've not been involved in it from the early days, even though I saw it from afar. So yeah, I've been here.
Okay, yeah, that sounds like a lot, and I guess we would have loads of things to learn from your experience in the industry. Okay. Today, we are going to be discussing security and just how software engineers can be conscious about security when undertaking their project. So yeah, Steph, what's your background in story about security? I mean, when we talk about security.
So I am not a security expert by any means. I don't specialize in security. I am just a normal programmer who happened to get into programming because I wanted to be a hacker. Funny enough. So my origin story like really ties into the whole thing about security. When I was younger, that was in uni, we used to fish each other. So that was how I actually discovered PHP, because PHP was used by we call them script kiddies, essentially people who can go online and find other people's code and use it to perpetuate exploits. So they don't actually write code themselves, but they use other people's code. So after I found PHP was how I actually became I started becoming a proper engineer, yeah. And it mainly was because we wanted to be hackers.
Yeah.
Like everyone wanted to hack. So and you can't hack without being a programmer. So here we are.
Okay. So what has your journey been from that point where you started like doing, let's say, fishing and trying out the scripts in PHP? Like, what was your journey from that point to being a senior software engineer?
I quickly pivoted to being a proper programmer rather than being like a hacker or someone into security, because I actually like building stuff. But the lessons I had learned from the days when I was into these shady things, I was never really a professional criminal or anything, but we used to play around with it, especially on each other. But after discovering some of these things, like being introduced to tools that could perform SQL injection on people's sites, you carry these things with you. So I've always tried to maintain a baseline security profile whenever I'm programming. By no means the most secure programmer out there, but there are certain things that I think that developers could pick up that would make sure that the programs they build are not completely impervious, but at least difficult enough for people to abuse, right?
Yeah.
So it's not just about security, it's sometimes about abuse of the system itself. Like people putting junk data in there, doing all kinds of stuff. So
okay, so basically just inferring from your background story, like what are some of the things that kind of you learned from those things that actually placed you on the path that you are currently on in software engineering?
Okay, so when it comes to the lessons I learned in security, there's always been one fundamental rule that you should always obey and adhere to, which is never trust user input. Like, it doesn't matter what the input is, never trust it. You would think that user input refers only to things like people entering their email and phone number or their password and stuff. That is user input. But when it comes to programming, anything that comes from the client is client input. So when you make an HTTP request, it contains a lot more than the info that the person has entered either in the browser URL or has entered in the username password field. There's headers, there's a whole lot that's packaged together and sent as a request. All of that counts as user input, because people, when they're attacking you, would always leverage either directly in the forms or even how they hit your server directly.
Exactly.
Right? You heard about the issue we had with the SSL thing. What was it called? Was it Heartbleed? I don't remember what it was. Okay, I believe it was Heartbleed.
Yeah.
I'm not sure again. But you don't hit that by entering the form. You hit that by making a call directly to the server and passing it data that it doesn't, let's say it doesn't understand, or data that would trigger certain things.
Exactly.
Like you would cause a buffer overflow, or you would do something, right?
Yeah, or maybe you are uploading a file of a larger size.
So, for example, with attacks like DDoS, with DDoS attacks, for example, you are looking at people sending too much information at the same time. All of that is user input, and all of that can be used maliciously.
Yeah.
So it's always, the fundamental rule is never to trust user input and to ensure that you are protected against user input. That's what everything stems from.
Yeah. So that brings me to the issue of validating user inputs. So now we have to talk about validation as a way of mitigating, like not trusting every input that comes from the client. So talking about validation, what kind of things can we look at in that aspect?
Okay. So when you are receiving any input from a client, the primary thing you want to always do is to ensure that you are validating that input. You must always validate whatever input it is. If it's an email, ensure that it's an email. Because remember, people will try to enter junk data into your site. If you're collecting emails, then the quality of your data is even affected.
Exactly.
Or they could enter anything at all. So you always have to ensure that the data that someone is sending to you is validated. Now, validation goes in different ways.
Okay.
We are talking about validating the type of data. If you're expecting a number, make sure it's a number. If you're expecting a number within a certain boundary, make sure it's a number within a certain boundary. If you're expecting data of a certain format, make sure that it's data of that format. If you're expecting a list, and you must always also do constraining. So you must always constrain the data that you are willing to accept. For example, if you're accepting a user description, you shouldn't give them the ability to enter as much information as they can.
Yeah, like meeting the amount of characters.
Maximum character. So constrain the data to certain allowable limits where the person can't send more than, if the person is creating a list, constrain it to a certain number of items in the list. You can create only 20, 30, 40, 50. But always put a constraint on it, else you're going to bother yourself. Then once you're done with validation, there is the other aspect of filtering and sanitizing. Some information that would come in, you want to filter it and make sure that the data that's coming in is acceptable. So if let me just use a very simple system. If you have a comment-based system and people are commenting, you don't want certain words to come in.
Exactly.
Like swear words. So you want to sanitize those words out of it. How you do it is different. I'm not going to recommend ways of doing it, but you should try to sanitize stuff like that, right? So the person comes in, they enter these words, they are banned words, remove them from it or prevent them from entering. Then you also have where people are posting data, where you are sending it out for other people. You always want to sanitize that information. So for example, if you're in a comment system again, and people can type, you don't want to render HTML in the browser.
Exactly.
Right? You are going to expose people to cross-site scripting and a whole lot of what do you call it? XSS, right? A whole lot of other things, because now you're allowing people to manipulate the content you are sending out. So as I said, if you do certain fundamentals, it protects you from a whole host of vulnerabilities. If you do validation, filtering, and sanitization, you've sort of covered 90% of the attack vectors that most people would use on you, right? Most people who are inexperienced wouldn't be able to go beyond that. Then you have people who are more advanced, who are able to craft way more serious, but that's not for the basic programmer who's trying to build a normal site. That is a little bit more for the security or infrastructure team to ensure that they are putting in firewalls, doing all those things, ensuring that nothing is coming at a high level. But today we are going to deal with people on our level. How do we do this validation?
Okay, so I think what you just spoke about, the validating user inputs, it's something that I can relate to personally, because in my experience as a mobile engineer, there are almost every time we are validating inputs, even users selecting files from their galleries, images, and videos that they try to upload. We have like size constraints. So if your file is above, let's say, 4 MB,
You say no.
yeah, you can't upload that to our server. Like we tell you it's too big. And then yeah, so as a junior engineer, I think most people start out in software engineering and then they just write code that displays maybe like an app bar. They do a screen, shows a bunch of information, make API calls, and I don't think even the books that we have on software engineering do actually lay out like a topic like security
Validation.
so
stuff like that.
in like how can the newbie engineer be very conscious of these things, because it's usually when things go wrong that you actually prompted about them.
So if you're a junior engineer on a team, then it is expected that you do not know everything and you are still learning. So whoever is leading and is in charge of pull requests reviews is supposed to look at that and ensure that you've done that. If you haven't done that, then that's a teachable moment where you can use that and say, hey, look into these things, understand why they exist. You can explain to them and then let them know. So for a junior engineer, you are not expected to know everything, but it's something that you should start picking up early. That's why I said, if you focus on even just validating, sanitizing, and filtering your data, you are going to have 90% of the issues solved. Like for most problems, there are a lot more things that you can do, but those would solve your problem. Now, you also mentioned something interesting that I want to talk about, which is that as a mobile engineer, you do a lot of validation. And
Exactly.
stuff. Now, we also need to be careful because client-side validation is not the best way to do validation. Client-side validation is purely a UX issue. It is to ensure that if the person enters information that you are not going to accept when they submit the form, you are telling them beforehand that, hey, don't do this because we don't like it.
Yeah. Can you take that again?
Okay. So if someone comes to your website, your mobile app, whatever, and they enter a phone number, but in the phone number field, they enter an email address, you want to warn them that, hey, the server is not going to accept this.
Yeah.
So this is not the format we want. Enter an actual phone number. And it's a UX thing. It's more of the experience that the user has so that they don't have to click submit before you throw the error. But your validations should always occur on the server. You can add them on the client side because it's a UX thing and it's great. You should do it.
Yeah.
If you're building an app and you can put in client-side validation, please do it. It's going to give your users a good time. But don't neglect to work on the server. Remember, someone can bypass your app and still make an API call.
Exactly.
Well, an HTTP call directly to your service and provide any junk data they want. So if your server is not actually validating what it's receiving, and you think that because your web page is validating, it's like, what do they say? What are them? But when I you know,
I wonder what that means.
It means that you think you're sleeping in your room, but your legs are outside.
I think another aspect of security that I encounter in my day job is dealing with API keys and kind of like configuration files that we don't want to sometimes push even to our Git server. We want to just keep them like in some secure location. Like, how do you deal with such situations? Are there any like rule of thumbs that are around such, like handling such situations?
Okay, so we spoke about junior engineers in the beginning. No junior engineer should be put in charge of deploying an application ever. You can guide them, you can work with them, you can do it, but they shouldn't be put in charge. Mainly because there are certain shortcomings that you as a senior or even intermediate would understand that they do not understand. So whilst you would want to work with them to do it, you don't do it. So someone in a senior position would be in charge of doing this. Now, someone in a senior position, I would expect to understand the concept of secrets. So what are secrets? Secrets are application data that you don't want other people to know about. For example, let me use your password. When you're logging into your Facebook, your password is a secret. It's supposed to be known only to you and to the server. Now, there are certain things that the server also does that requires things like passwords.
Exactly.
API keys, as you mentioned, for example, are an example of machine-to-machine authentication keys, right? So they are also passwords. You want the server to know it so it can make a call. So, for example, maybe someone is making a payment. I want to talk to ZPay and say, hey, ZPay, charge this person's account. ZPay needs to know it's me, so I need to authenticate with ZPay. They give me a private key, an API key, whatever it is, whatever authentication material they give me. It's secret. It's only meant to be known between myself and ZPay.
Exactly.
So just like your password, which you don't want other people to know about, how do you handle these things? So all secrets should be available in memory in the application. So when your application starts up, you want to have it available in memory, but you don't want it persisted somewhere that people can see.
Okay.
So most often we would put these keys inside of the environment. So if you have an application, you put it into the env, and whenever the application starts up, it picks these secrets from the env. Now, certain programming languages or frameworks would allow you to create local env files. Let's use Rails, for example. You can have like a settings file, and you can have a credentials file. A credentials is secret, which you commit in the repo, but it's encrypted. Others would not allow you, don't have that at all. So most of some would, allow you to do like these .env, usually when you're programming. And we tend to
like
make
those .env files.
Yeah, .env files, like which will allow you to specify a local one. It's
like
usually for testing.
Yeah.
Like for testing. So maybe the test code, you want it in there. But some people would either leave their secrets in there, or they would hard code the secrets inside of the application. A common example is database access. Most people hard code their database username and password in the code. Into it. Yes. Database access is, again, anything that gives you, that authenticates you to someone by, like for a rule of thumb, if it gives you access to something as yourself, if it authenticates you, you should treat it as a secret. And you should not expose it either in your code base or in your, how do you call it? Or like on disk in your app, right? So if you have it in memory, it's only available in memory. Then that works well.
Yeah, I think in my time dealing with like CI environments, I think we stored the configuration or like very secret keys that we wouldn't want to be exposed in the environmental variables.
Yes.
And then when the application started, we used these libraries to fetch them
and
into
then
memory
use them.
and then we use them. But like people can argue that these things are secure until someone finds a way to hack into them.
So let me ask, does it mean that because someone can come and break your front door, you won't lock it at night? Right? What would you instead do? Would you lock it and make it? Yes, make it harder for someone to break in. It doesn't mean they can't break in. Like people break into banks. It's not your house that they can't break into.
Burglar proof.
Exactly. So you can choose to leave everything open or try to secure it a bit. Remember, security at its best is usually a best effort thing. You are putting in as many stumbling blocks to prevent a potential attacker. But if you're a juicy enough target and an attacker is dedicated enough and funded enough, trust me, they will break into your systems. Like they break into Microsoft, they break into Uber, they break into everyone. They even break into the federal FBI sometimes. So security is the best effort at its most. So do the best effort you can and pray.
And then just moving our conversation to the back-end side of things, because usually back-end systems are like the heart of most applications that we use these days. And we've talked about validating user inputs and setting constraints here and there. But kind of talking about back-end security, I think I've read a couple of articles where people argue that an authentication system like, let's say, GWT isn't secure And then you see some people on the other side of the internet, engineers, who argue that it is secure. And then these conversations keep going on. And then you would ask yourself, like, if I were a backend engineer, like, what would I choose? And say I decide to go with JWT. Are there ways I can use an existing technology, even though it has like vulnerabilities, and try to work my way around it?
I wouldn't say you should use an existing technology if it has vulnerabilities. I would say that with every technology you use, understand the trade-offs. JWT does not have vulnerabilities.
Okay.
How you implement your usage of JWT could introduce vulnerabilities. Does JWT have trade-offs? Definitely. But does it have a purpose? Yes. So I know we are using JWT here as an example, but every system you use has trade-offs. API keys, for example, let's look at certain common authentication schemes. Keys, static API keys, server secrets. They are long-lived. That means that if it gets breached, if your API key gets breached, the person has access to it forever until someone changes it.
Exactly.
And usually server secrets are not rotated that often, right? And usually server secrets are not rotated that often. So there's a vulnerability there. There's a trade-off there in ensuring that the person keeps it secret, and then people implement rotation policies. But does it have a use? Yes, because it's quick to authenticate. If I give you an API secret and you come, I'm able to check against the database. Does this guy's key match the hash of this? Exactly. It's a very quick query. I confirm, I move on. So I'm trading off performance for a potential vulnerability. But then you put in fixes on the other side to cater for it. Now let's look at another way. Cookies. You can't use cookies in a mobile app.
Cookies are used in the browser.
In the browser. You can't use cookies in a mobile app. Cookies can be vulnerable. Like people back in the day, we used to put data directly in cookies. So the user ID will be directly in the cookie. And you could go in, edit the cookie to another user ID and gain access as that person, right? Now we know that this is wrong. So either we do things like we do a cryptographic hash of the data in there, ensure it, or we encrypt the data before we put it in the cookie. So there's always ways that the way you implement the technology would either mean that you have a vulnerability or not. Then we go back to JWTs. JWTs have two properties by default that you could choose. They are not turned on by default, but you could turn them on. You have a cryptographic signature, which means that you have a secure hash. That means if someone is given that token, they can't change the data without tampering with the signature. And they also have native encryption involved. So you could encrypt that data as well, and you could do it. Now, you could take a JWT token and stuff it into a cookie, and it would work because you are leveraging the cookie as a storage system, but then the way you are actually verifying the data is checking that it's exactly. So JWT is an authentication mechanism with trade-offs. What is the one trade-off that it has? The one trade-off that it has, funny enough, is the one biggest advantage it has. It is stateless. It means that you can't, once you've sent out a JWT, you can't revoke it. If you're using JWTs, right?
Yeah.
Because a JWT is not meant to have any...
Until its expiry, right?
Exactly. People sometimes get rid of that. Like me sometimes, depending on the application I'm building, I put a value in the JWT and check if it is chained on the server. And if it's chained on the server, then I consider it invalidated. But then I'm losing one of the biggest benefits of using JWTs because JWTs are stateless. And then when a call comes, I can take that single JWT without cross-checking anything else.
Just
verify that data is correct. Exactly. But by using it the way I am using it, I'm only leveraging the encryption and the signature that is giving me to verify the tamper-proofness of it. But I am not benefiting from the statelessness.
Solely dependent on it for your security.
So how you implement it is fine. Tools are going to be used. Just make sure that whenever you're doing something that especially relates to a secure part of your application, you understand that system well enough. That technology that you're going to use, understand it. What are the trade-offs here? What do I need to do if I am going to use this? Am I okay with them? If I'm okay, then you go ahead, or you don't. You choose an alternative. And that's what we do as engineers. Find the best solution to a problem within the specified cost and time.
Yeah, I think when you were talking about the JWT authentication, you mentioned about the implementation. So let's say I go to an open source project and it's an implementation of the JWT.
Okay, so I didn't mean the implementation of the JWT as in the implementation of the library that supports JWT. Yes, those also can cause vulnerabilities. Like maybe you go and use someone wrote his code to write JWT, not well tested, and then all of a sudden we find out that it's vulnerable to certain attack vectors. That is a library. That is an issue with a library, and that's why one of the things when it comes to security is to ensure that your dependencies are well vetted and always up to date. Anyway, that wasn't what I meant by implementation. What I meant by implementation was how you implement it in your application.
In your application,
In your application, yes. Not the libraries, but the libraries too can open you up to a vulnerability.
I think as engineers in our development process, we do use like libraries here and there, adding them to our projects in packages or gems in some language. They call them gems. So I just wanted to ask you, like, is there any vetting process around choosing libraries? Because some of them have vulnerabilities. Like if you look through the code, you can see, like, you can notice some things that aren't done like the more secure way. Like, is there any process around choosing libraries?
So that's the beauty and the ugliness of open source code, right? When you are dealing with open source code, you get what you get. It's up to you. Can you do a security audit of every tool you use? No, you can't. So that's why we hope that other people in the open source community would be doing these audits. You might have seen GitHub CV reports. If you've enabled Dependabot, for example. Dependabot will warn you about
that thing is always disturbing.
It's so annoying sometimes, but you have to do with it. It would warn you when a library that you're using in one of your projects has been detected to have a vulnerability.
Or it's out of date.
Or it's out of date, too out of date, you should update. So those are tools that you can start using to help you. But usually when you are choosing a library, you want to find something that is trusted. For example, it comes from a bigger, well-known, well-trusted company. For example, if I see a Shopify gem, I am more likely or more inclined to trust it than if I saw that the gem was written by someone who just switched from Node, right? So no hate, Node guys. But like you have to also vet the publisher of the library that you're using and stuff like that. We can never really catch all vulnerabilities because that's code. And the more code you add, the higher the surface area and the more potential for bugs that you introduce. So use the tools available to you. Dependabot, CV reports. Let's pray the open source community is helping us. And
and then personally, I like automation. I like just automating my processes because part of me is lazy. And as engineers, I don't think like most engineers spend like a large part of their day or their sprints trying to do security stuff. They are mostly focused on building products and getting it to market.
Correct.
So are there ways an engineer or a team can build like some fundamental checks into their code base to just kind of catch like bugs early? Are there any ways we can do things like that?
So one of the things we should remember is if we arm ourselves with the basic tools of security, then we would in general like be protected and well, as I said, get rid of about 90% of vulnerability just by doing certain basic things, right? So if we were able to get ourselves armed with the basics, that would be our first way of fighting back. The second thing would be at the code review stage, where people with more experience should also take a look at these potential bugs. Like if you're writing database access code, I'm going to check, are you using, what do you call them? Parameters or placeholders. I don't want to call them placeholders. Or are you inlining your variables directly into the string? If you are, then I would raise that as a flag and say, hey, use a prepared statement, use a parameter query, something like that. And instead because of the potential for vulnerabilities.
Yeah.
Or if you're using a language that doesn't, or a framework that doesn't support it, then quote your variables, right?
Yeah.
So your second check would be at the code review. Then at the higher level, apart from that, you have a CI system. Your continuous integration system can integrate certain open source tools out there. I don't have a comprehensive list, but tools like SonarQube, there's others that do the OWASP checks. There are quite a few tools that will do static and dynamic analysis of your code.
And you can incorporate these tools into your CI.
Okay. So your CI, if whatever you're using, would run that as a check.
Yeah.
And like the way you do maybe your testing and your test coverage report, you run like a SonarQube analysis. You run whatever other tools you're using to run your dynamic and static analysis and give you a report. You could go through this report periodically and then say, okay, look, we have these vulnerabilities, these potential issues. Let's fix them. Even linting can help you. So if you use something like JavaScript, which you can make mistakes and certain mistakes can help you to vulnerabilities.
I think JavaScript, they have the ES links, I think.
Some of these links would tell you like, don't do this. This might potentially open you up for vulnerability. Even that, for example, has its own lint where to tell you, hey, there's, but sometimes it's just programs and syntax.
Yeah.
But you have linting tools that would also help you know. So, well, linting falls under static analysis, right?
Yeah,
so,
I think tools that are built around it, like basically do the same checks
kind of thing. So, your CI system, you could integrate these tools that would help you scan. And what else? If you have the big budget for it, then you could have periodic pen testing and stuff like that. If you're a big company, especially dealing with money, you should do this stuff anyways.
Yeah. So with you being in the industry, and I know you've hired engineers to work on large projects. Like in your interview process, how do you test software engineers for this basic security? Or you want to be sure that your engineers are security conscious and not just writing code that works? And like how do you interview that?
Generally, depending on the level and the kind of job you're coming to do. So if you're coming in as a DevOps engineer, there will be different questions I will be asking you, right? Pertaining to how you're going to secure the network, how I'm going to mainly try to ask you best practices. Like, so if you're setting up a network, how would you set it up? Open-ended question. Let the person talk about it. An architectural review. One of the ways that is more effective is also in take-home assignments. Yeah. So when you have a take-home assignment, then you're able to get people to come back with their code, and you can look out specifically for certain things. Are they validating their code? Are they reporting?
I wish someone had told me that was probably the goal of like take-home assignments.
Take-home assignments.
Like, every time I see take-home assignments, I'm like, I'm not going to work for free. Like
sometimes the take-home assignments are trying to get you to work for free. Yeah. But in some instances, it's the only way to evaluate certain skills. Yeah. I don't like them myself. I generally prefer to have a more verbal discussion with you to understand how you think, because I'm more concerned about the thought process. So in general, depending on the role you're coming to play would determine what kind of questions. And I would generally keep them open-ended. So throw a question to the person, like, if you were designing an API that signed up a user, how would you design it? Yeah. Allow them to choose their technologies, whatever. If they skip a step, ask them. So at this point, what if I enter a phone number and find out if they've already thought about it or they are now thinking about it, because that has an impact. Things like, okay, so what kind of authentication scheme are you going to use? Like, I'm going to use JWT, whatever. All of those are included in how you would evaluate someone. So open-ended but directed. So you keep it open-ended but keep directing them in a way you want to understand whether they really understand what they're talking about or not. It's hard to interview in any circumstance, right? So judging a security mindset itself is in itself also pretty difficult. Yeah. So working at like a tech organization, I have experience working at like smaller companies, but like in the case where we detect a vulnerability, or maybe someone is able to hack into our app and then they maybe steal money away. Like, are there processes that actually, well, they would be able to fix the issue, but then
would the developer be in trouble? Like, are there systems around situations like that?
So I don't believe that any organization should deal in blame game. If you work in an organization that works on blame game, then it's problematic. If someone makes an honest mistake and you figure it out and you try to correct them and they don't, then they are not a valuable employee.
Yeah.
You let them go. But if someone makes a mistake and you blame them for it instead of trying to fix it, then it doesn't really augur well for the reputation of the organization and how they treat their people. People make mistakes. Trust me, I've seen senior most engineers make mistakes, like basic mistakes. And you can't blame people. The only way you do it is you look at what is there, what happened. You do a root cause analysis. Once you run a root cause analysis, figure out what went wrong.
Yeah.
Then you can come up with procedures to prevent that from happening in the next time.
Yeah.
So if something happens the first time, every organization that is smart would investigate to find out why it happened. If someone was negligent, negligence is a different thing from making a mistake.
Yeah.
If someone's negligent and there's punishment to be meted out, fine. But you want to build upon that learning and improve and prevent future occurrences.
Yeah.
You can't just be blaming everyone. You're going to destroy morale.
Yeah.
And stuff like that.
Yeah. So how should junior engineers approach security? Because imagine I was a junior engineer. Maybe I have just 1 year writing backend systems, and those systems just live under my bed. Like I've hosted them on Heroku and just tested them myself. And then I get into an organization where I'm in charge of an e-commerce application where I'm processing payments. Yeah. Like knowing all these things, there could be that like lurking fear around in my head. Like one day someone might exploit my system. Like how should I approach it such that like I'm still able to write the code and not scared of like me, like just kind of being scared of like making the wrong choice.
Scared of making a mistake.
Exactly.
So this is why it's important for seniors to, especially if you're giving a junior a security sensitive task, to first of all walk them through. Right? If you're giving a junior a task and you can walk them through what it is, let them understand what they need to do. And if there are any things that they should keep out, like look out for, like let them know and point them in the right direction to find information. So when you do that and they are approaching the problem, they feel more confident. They feel like, okay, I know what might happen and I have learned about this, so I am more confident. And then the second process is the code review process. That LGTM thing, it doesn't fly. Like actually look through the code. I know we all do it.
Looks good to me.
It looks good to me. Shout out to Drakel. I think what's his? Oh no. His is everybody lives at stand up.
Yeah. Lead for stand up.
Yeah.
Oh, Drakel's own is the lead, right? For stand up.
So wait, he did an episode where he said everybody lies.
Yeah, everybody lies at stand up. Yeah, okay. Like.
All right. So the second part of it would be the senior making sure that they've reviewed the junior's work properly.
Yeah.
And then try to catch some of these things. Otherwise, then you would never build a confidence in them to allow them to go ahead and do it. Even if they become seniors, it's important for you to still review the code. Like
review the code.
They might make mistakes. Right? It's less frequent for a senior to make a mistake than a junior. Yeah. But you don't review that code with any less thoroughness. So everyone should always. It's a team. That's why if you're blaming, then who are you blaming? Are you blaming the person who wrote the code? Or you're blaming the one who reviewed the code? Yeah. Or you're blaming the one who released the code? Because we all play the parts in it.
There are lots of moving parts to this.
Exactly. Yeah. Or the one who tested the code.
Yeah. The QA tester.
The QA tester.
I think most of the time we blame them because like, why didn't you see this?
But why did you not see it as the engineer, right? So it's a collaborative effort that you want to build upon. You don't want to blame anyone and then cause any bad morale. Yeah.
All right, Steph. So it's been a fruitful conversation with you talking about security and how junior engineers should approach security and kind of like tips, things we should be conscious about, validating inputs, setting like constraints, how we should choose our libraries, vetting them,
Yep.
reading documentation, and just being updated with like versions, and just being conscious of all these things, and kind of like incorporating this static analysis tools into our build pipelines, using environmental variables and all these things. Yeah, it's been a nice conversation with you, and I'm really grateful you are here to run this. Do you have any final words?
I'm happy you had me. It's been a long time coming,
Yeah.
right? Like we've been planning on doing this for a while, and I'm happy we finally did it. Maybe we should meet soon and do a more in-depth, more advanced study of security.
Exactly.
Yeah.
Exactly. I'm absolutely down for it.
Yeah, I have a few people who are actually more into security that we could have a proper discussion.
Yeah,
with.
that should be fun.
That would be great.
Yeah. All right, Steph.
Fine.
So how do we even do this?
What was that?
All right. Thank you guys for listening to the Comrades podcast, and
TCP.
probably have another episode soon. See you guys. Bye-bye.